Today we're talking about the time series element in GoldSim. The time series element in GoldSim is quite feature rich and can do a lot of different things in a lot of different ways. And now with some added features in our upcoming release, which we are right now in the process of printing the documentation for it. You should see it very shortly. It does have some powerful new features, which I'll go over in this webinar. This webinar, I plan to cover the basics of the time series, but I'll also show you a lot of advanced stuff here. Right, this file or this model that we're looking at comes with GoldSim. If you go up to File and click on Open Example and go to the time series examples, then you'll see this one here. This just walks you through a lot of the basic features of the time series. If I run this model, we can look at the different ways in which a time series can be represented. So I'll go in here to the compare representations, and it just walks you through the different ways the time series are represented in GoldSim. So those of you that are new to GoldSim, to create a time series element, you go into the graphics pane and you right click and select Insert Input Time Series. And here's the time series element. This is how you represent time series data in GoldSim. So time series elements in GoldSim provide you a way to give the model a input that changes through time, and it's kind of your boundary condition on your model, on your input. You can also record time series. So as you know, GoldSim is a dynamic simulator, so the results that it's generating are time history results, or can be time history results that vary through time. So you could record those results into a time series as well. But most of the time, people are using time series as inputs. So here we have a list of time series, and the first one is the default, Instantaneous Value. If I open up this time series, you can see up here is the name, description. You can put in units. This doesn't have any units right now. You can also specify the data type of the time series, meaning whether or not it's a scalar, a vector, or a matrix. You can also specify whether it's a discrete change, which I'll go into next, or in a little bit later. So here we can specify, if this is a vector, for example. Now, it's important that you keep in mind the difference between a vector time series and a vector data. If we were to look at a data element, which is just a constant, right? So we just put in some number here. This is some constant in GoldSim. You can create a vector input. If I change this to a vector type, then we get something like this, where you have a table, and you could have as many rows as you want in here, but that's how a vector is created. Now, if we have a time series, and we make the time series a vector, it looks different on the edit screen. So down here where I can click on the edit data, you'll see that instead of showing multiple rows, we're showing columns. And that's just because the rows are already taken up by the dates. Okay, so if I go back to our first time series, and we look at the edit data, you'll see that we have day is the time unit. We start at 0 days. After 100 days, the value is 5. At 300 days, the value is 25. At 400 days, it's 45. So what's interesting is when you're working in a spreadsheet and you have this kind of table right here, it's always taken for granted what this actually represents, or it's actually nebulous in the spreadsheet. What do we mean when we say between time 0 and 100, the value changes from 10 to 5? Does it change linearly, or is it constant? And is it constant over the period from 0 to 100, or is it constant from 100 back to 0? There are a lot of questions about this, and they have to be defined. They have to be explicitly defined in GoldSim. So that's why we provide these options here that says, where it says represents. On the represents button, you click on this, and now you have the options of how you want the data to be represented. Currently, this first one is set to be instantaneous value. And what that means is, when we look at this data, that on time 0 the value is 10, on day 100 the value is 5, and when we're in between those 2 points, GoldSim interpolates linearly between those 2 values. Okay, I saw somebody notified me. I don't see any questions, so it looks like we're okay. All right. So let's run this model and see what those results look like. Okay. So here you can see that the results are linearly interpolated between time steps. But what's important about this is we need to know what the time step is, because it could be that there's a line here showing that there's an interpolation, but it may not be the fact. It may be that that's just our time step. So what we want to do is make sure that we're showing, sometimes in these cases, we want to show points to make sure we know where each of those are. And you can see there are so many points in this, there are so many time steps in this model that it looks like just one big thick line. Okay, so if I go up here to the simulation settings, you'll see that this runs for 400 days with 1 day time steps. Okay, so if I were to change this to, say, 100-day time steps and run it again, then you would see that I would have a point every 100 days, and the lines that are connecting these points are not actual calculation or result points in GoldSim. GoldSim just draws a line between those values that are recorded. Okay, but if there's a time step that occurs between any of these 2 points, this time series that's called instantaneous value, it will put a point on where happens to be where this line is showing, linearly interpolating between these points. All right, I'm going to change this back to be one day time steps and do it again. Okay, now let's talk about constant over next. Constant over next is how this time step is specified. If we look at this chart, then what you see is the same thing, but instead of linearly interpolating between the points, it's saying that I have that value that holds constant over that time step, and then it changes as soon as the next value, or as soon as a value changes in the time series. And here's the table. You can always switch to look at the table, but this shows you the values of every single point. If you want to look at the table of the data that's entered, you go to the time series. In the time series, click on View Data. Okay, so there are some other ways that we can represent the data: constant over previous, constant over next, change over previous. Change over previous is interesting because this might give you the ability to look at a rate of change very easily without having to worry about converting based on calendar time. A good example of this is precipitation data that's being recorded in a cumulative manner. So you enter the data in a cumulative way. GoldSim then can calculate the rate of change based on that cumulative amount for you. Even if it's a calendar simulation, you don't have to worry about, for example, the changes of the length of a month. So if I open up this change, this is showing us that this is the cumulative amount, or the amount that has changed since the previous step as we move through the time series. If we look at the data, you'll see it's exactly the same as the other ones. But what we're doing is we're reporting the amount that has changed since the last time point. So we go up 10, we go up 5 more, we go up 25, and if we look at the chart, you'll see that we go up 10, right? Then we go up 5, and we'd have to look at the details of it, but that's how that's changing. You can also specify a discrete change type, data type. So if I go to this time series, and if I go to the type right here, you'll see that the type is set to be discrete change. Okay, and now once you do that, you can only represent that one way. Discrete changes are only just discrete changes. They can't be a continuous. So these points only occur right at those times. There is nothing that happens in between these times. So the only way we can really view a discrete change output is with an integrator in this case. You could also show it into, you could also apply this to a reservoir. You could also put this into a delay element. There are a few other elements in GoldSim that accept discrete changes. But this would be for more of like a discrete change model, something where you're processing transactions, for example. If I were to run this model, then if we plot the result, this is actually the result of the integrator showing us how much discrete change passed through at those events which occurred at time 0, 100, 300, and 400. Okay, so what are some of the things that we can do with time series elements knowing this? Let's look at some example models. Let's see. Okay. Let's look at this historic future example. Okay, here's a model that when I run it, this runs probabilistically. I just ran this model for 100 realizations. If we look at this chart, what we see is that we have some historic data that runs up to some point, and then when we get to a point that represents moving into the future in our simulation, we go probabilistically forward. And so what this might represent is a model in which you're trying to simulate a historic condition up to some point and then moving forward into maybe like a reliability model or something going forward. And so the way that you would set something like this up is that you would run the entire model probabilistically, but only use probabilistic results or probabilistic inputs after some point in time. And so what I have here is a historic record, and that provides us what's happened in the past. And then I have synthetic data that represents the future. And then all I do is I just use a selector that says after some given point in time, well, before that point in time, use the historic record. Before that, use the synthetic data, which represents the future. Another example is that we can do time shifting. Let's say that we have a model that has some amount of flow here. If I click on this edit data, then you'll see we have historic data from 1923 all the way through to 2010. Okay, and so what we want to do, I'm going to move this out of the way. What we want to do is we want to do statistics on this stream flow. And we want to look at, let's say on an annual basis, what is the peak flow annually for those, let's say, about 90 years of data. Okay, so using Monte Carlo and the time shifting option, we can very quickly, with just a few elements, produce statistics on some recurring interval, and let's say that's just 1 year. So what I can do is I can set up a simulation that runs just for 1 year, and it doesn't matter necessarily what year we're picking, but you just need to be aware of one thing, and that is of leap years. Okay, so this model is, the simulation period is is 2010 to 2011, so that's not a leap year. So there are 365 days in this year. Also, just a quick note, I've noticed a lot of users are doing this kind of a thing. They'll say, I want to run a model for 1 year, and they will do something like this, sort of. I think it's something like, or I've seen different things in the time, but they'll go to the last day of the year, of the current year, the start year, and then try to get as close as they can to the end of that year. And I guess you would end up doing something like this: 11, 59, 59, but that doesn't make a lot of sense, right? I mean, we're so close to 365 days. I recommend that you just go to the next year at midnight, and it's the same thing, but it just gives you a nice even number of days in your model. I mean, this is really just 1 year right here, right? Because we're stopping at midnight. All right, so we're running for 1 year, and then Monte Carlo, we're going 100 realizations. Now, technically, we could say, well, I only have 90 years of data. I don't remember exactly how many I have, but you'd want to just run as many years that you have data on. So in our case, we have about 90. So we want to run that many realizations. And so now when we run this simulation, what we can do is we can see for each year that we run, let's go into the time series and let's pick a new starting point for a simulation. So if I look at just one realization, this would be just one that's realization. I'm only showing one realization. Just a second here. Let me go back. Oh no, I'm screening. I forgot about that. I'll talk about that in a second. But anyway, so here's one realization. Here's another realization. And in this particular model, I'm only showing certain realizations because I have screening turned on, which I'll talk about in a second. But anyway, you can walk through the realizations that are included in this run. And all I'm doing is just randomly, well, actually, I'm not randomly. I'm picking different points in this time series, and let's talk about how that's being done. So if I go to the properties of the time series, and then if you go down to the advanced, you have to click the More button in the time series, in the default time series. When you click on that, you'll see down at the bottom it says Enable Time Shifting of Time Series Data. I click on the settings here, and now it says I have two options. I can either use a random starting point on an annual basis, which is what I would want because I'm running an annual simulation here. Another option, well, you can change the periodicity here. You could say diurnal too if you were doing a one-day simulation, for example. You could also say none, and that would just randomly go through the entire time series, just anywhere, and it would be just totally random, and where it would pick a starting point for the simulation. So what that means by starting point is that in our case, it will go on an annual basis. So we told the simulation to start in January, on January 1st. So it will go randomly and pick January 1st out, or January 1st points out of the time series. It's totally random. And it goes in there and picks a starting point, and that's where our simulation begins. And then it just walks through that time series starting at that point and goes chronologically through until we hit the end of the simulation. And each realization, it picks a random point. So this could be useful. A lot of people that deal with historic time series like this, though, have asked to instead of looking at it randomly, they walk through chronologically through each year, or I should say sequentially through the time series. And that can be done if you click on this. You say Shift Data Years align with the simulation dates. And in our case, because the time series starts in 1923, we would say I want to start in 1923. And then what GoldSim will do is it will just start there. And as we run the simulation, then it can shift forward from that point. Okay. So if you have multiple time series in your model and you want them all to be aligned for each realization, so if you run realization 7, you want them all to pick 1930, then you would not use the random option. You would use the shift data years to align option. Okay, so now what we can do is on an annual basis I can accumulate the flow annually, and then I can calculate an average on that annual basis, and I can also look at the peak using a maxima, or I'm sorry, extrema element here, and then we can do statistics on it. So now when I run this model, we can look at the statistics here. So this is the annual flow volume, a volumetric flow probability distribution, and here is, let's see, CDF. Here is the peak flow. I have actually peak flow and average flow together here. But what you probably noticed when I first opened this was in the table we're missing values. You can see here that we're only showing a few values. Well, the reason for this is because I have screening turned on, so let's talk about that. One thing you can do in a GoldSim model is you can specify certain realizations that you want to screen out in a chart, and that's what's being done. So in this case, you could do something like this. For example, you could say for these given conditions, I only want to show certain realizations and I want to color them in a certain way, right? So realizations that meet some criteria, let's say a high maximum flow, I want to color those purple, magenta, and flows that are very low, I want to color red, for example. So those are things you can do with screening, and to get to screening, you click on the properties, and then from here you go to the options here, and then down here is where I have all the screening occurring. And in the screening, all you need to do is just type in a condition, and you can reference elements in GoldSim in your model here, and then you set up your conditions, and you can check and uncheck the ones that you want to show. So if I unchecked both of those, then this would only show me those realizations. So it's a nice way to screen. Now this is a global setting. Okay, so every result that you look at will have these settings. If I uncheck these two, that applies to all charts in GoldSim. Okay, so that's why just a few are showing up, because I've screened out the realizations that had very low flows in that model. Okay, let's talk about another one. So I mentioned time shifting. There are different ways to apply time shifting. It depends on your application, but we get quite a few requests from customers about this, and so I just wanted to kind of walk through the different types of applications that we see. Sometimes people have a short duration simulation, and I'm just walking through this list 1 through 4 right here. Sometimes people have a short duration simulation, but they have a long time series data set, and that's what we just looked at. So it ran for just a year, but we were picking through this long time series, and graphically what you see in that case is something that looks like this little image down here on the bottom. So well, this is not exactly what we had in the other example. The other example was random. This is doing a sequential shift on the time series. So let's go to the properties of this time series element. I open up the properties, and then I go to well, let's go to the edit data first. So 1921 all the way through 2003. If I go to the settings here, the time shifting settings, what you'll see is I'm using what I was mentioning before, shift data years to align with simulation dates. So on each realization, I'm looking at sequentially moving through time, starting with 1921, starting year, and it's based on the realization number. So as the realization number increments forward, then we move through the time series, starting with 1921, and it will align the dates based on the simulation settings. So we probably specified for this to start in on January 1st, so it just goes January 1st, 1921. On realization 1, this returns a 0 right here, so it just stays there, and then we walk through the years as we move forward. So what you'll see in your simulation, which is shown here in red in this graphic, then what you see is the time series record is in black. So realization 1 here, 2, 3, etc. Okay, somebody asked a pretty good question. Let me see if I can get that open again. Somebody asked, can time series settings be controlled programmatically from outside the GUI, from outside GoldSim? The only thing I can think of, well, the easiest thing I can think of right now is on your time series. Let's create a new time series here. So I didn't really mention the data source yet. That's this first option. So everything we've looked at has been locally defined, which means you just type the numbers in here. But you can also import directly from a spreadsheet. And if you did that, then if you had a way to change your time series and export that to a spreadsheet, when GoldSim runs, it could then pull that in at the beginning of the simulation. You can also link to an external time series definition, and this is something that would be created from a submodel, but that's not really what you want. So it seems like that would probably be the route that you'd want to go. Is maybe you would edit the time series from a spreadsheet. I wonder also if you can call GoldSim from the command line, and you can specify parameters within the command line, but I'm not sure about time series. I'll have to check. Let me do that at the end of the webinar. Please remind me at the end, and I'll see if I can get into that. Okay, so you're happy with the spreadsheet option. Okay, good. All right, next one. Let's say you have a short duration, long time series, but it's an elapsed time model. How would you do that? Well, let's open up this little example. By the way, I can provide these examples for you after the webinar if you're interested. Okay, so what this one does is we have a time series here that just walks through time on an elapsed time basis, not a calendar basis, right? So we just have a number of months. Starts with month 1 and goes all the way to month 984. Okay, so how would we sequentially walk through, or how would we randomly pick values from this on an annual basis, on a pseudo-annual basis? Well, what we do in this case is we'd say, let's just go annually, just have random starting points, but the data periodicity is annual. And so what it does is it says, well, every there are 12 months in a year. This is a monthly time step model. There's 12 months in a year. GoldSim just assumes that there's 12 months in a year, and it says, okay, every 12 months I'm going to say that's a year. And so on each realization, it will randomly pick starting points that, if for example you did a modulus function on e-time, you would find that you would hit 0 every increment of 12 in there. That's essentially what this is doing. If there's an increment of 12, then that's a starting point, and it's randomly finding those points in there. I suppose you could also build a little function that walks sequentially through there, but that's how you do it on an e-time or an elapsed time basis. Another one is you might have a long simulation, runs for many years, but your time series is very short. This is a little bit dangerous, right? Because what this is assuming essentially is that time series is repeating. It's cycling through multiple times. You're using it over and over and over. And if that time series does not represent maybe an average condition, you could be confining your model in a way that it doesn't represent reality, right? So just be careful with that one. But let's go in and look at it. So let's say I have and let me look at I'm going to the properties of the submodel to see the time. This is running for 10 years on a 1 hour time step. So that's a lot of points. Quite a few points. Okay, if we look at the time series, what we have here is starting 2011, going all the way to 2012. So just 1 year of information. And so what we do here is we say, okay, I just have, oh, maybe it's 2 years. So the time series record has 2 years of data, and every 2 years of the simulation, we apply that time series record to those 2 years, and then the next 2 years in the simulation, we apply it again, and we're just cycling over and over again. Let's run this model and see what that does. This is going to be kind of hard to see, but this is cycling over and over. If you look at these spikes in here, you'll see that there's a pattern, right? It reoccurs over and over and over. Something that you want to be aware of, though, is leap years, right? If you put a leap year in here, which we do have one, 2012. There's 366 days in that record, but that may not line up with the 366 days that it's in the simulation right here, 2015, which it doesn't. So over the long term, it should work itself out, but just keep that in mind that GoldSim doesn't do any magic for leap years. It doesn't automatically remove a day from the time series to say, oh, this isn't a leap year. So just be aware of that when you're using the short time series. Randomly sample multiple time series elements. Okay, so I mentioned earlier that you might have multiple time series and you want to sample from them randomly. That can be done, and I'll show you how. So in here, what you might want to do is you might want to randomly sample your time series. So in this simulation, it's a short simulation. Each realization picks some starting point in the time series. The time series is shown in black here. But what if you had 2 time series? You had a time series of flow rate and a time series of rainfall. And you want to randomly pick points in here, but you want them to be picking the same point in each time series. So what you want to do there is you want to create your own sampling starting year. And I'm doing that by creating a stochastic that is a discrete distribution, and it just picks years from 1932 all the way to 2012. And it's doing that with equal probabilities. Let's see, if we looked at a cumulative distribution, you'd see that they're all equal probabilities there. And so what this does is on each realization, it picks a random year. So it's just going through and picking randomly a starting year. Okay, and then it's called year select. That year select is then used right here, shift data years to align with the year select. Okay, so that's a way to, and then that year select is used for both time series. So you could have lots of time series in your model, and they're all being picked randomly or indexed randomly for each realization to create your multiple time series as you walk through this simulation. Notice also this is not just a 1-year simulation. I'm doing a 5-year simulation. Did I note that in here? Yeah. So this is a 5-year simulation, and it's just all that our expression year select, this random number, all that's doing is picking a starting point. So it picks the starting point 2014 for this realization, and then after that it just walks through the time series. So we're not picking a random point every year. We're just picking it at the beginning of the realization. Okay. So there are multiple ways of shifting through a time series. All right, let's go ahead and do this one. So we have a new feature. It's a lookup function on a time series. A lot of people have asked for the ability to reference a time series but not reference the point at the E time of the simulation. So just to back up a little bit, on a simulation, you specify either calendar time or elapsed time, but you're walking through time. All the calculations are done from your start time, and then on each consecutive basic step as you walk through the simulation. So every time there's a new step, GoldSim updates all of its calculations, and it just starts at the very beginning and walks through. So without doing anything extra, when you reference a time series, you have to reference the point that corresponds to the time in the simulation. Well, we've created an ability to add an argument to a reference to a time series that allows you to reference a different point in time. And so what this model does is it shows you the comparison of some time series. This thing's called flow data. And this walks from day 0 all the way through day 365. Okay, and I have two expressions here. One that looks forward 20 days, one that looks forward 40 days. If I open up the 20-day expression, you can see that we reference the flow data. And by the way, to reference a time series, let me just talk about the default reference. To reference a time series, I'm just putting the units of cubic feet per second here. Flow data. This is how we would, by default, reference a time series. We don't have to put any arguments in here. We just say, I want the flow data. It tells me what the flow data is right there. In fact, I could just say current time, something like that. Okay, so now what we can do is we can do a look ahead. So in this expression called ahead 20 days E time, if I open that, then you'll see that I'm now looking at the current time, the current elapsed time, and then I add 20 days to that. Okay, now there's this little additional parameter that you can add. You can add either a 1 or a 2, and that just tells you whether or not you are trying to reference an elapsed time from the start of the time series, or whether you're trying to reference a date, a calendar date. And in our case, we want to reference the elapsed time from the start of the time series, so we specify a 2. By default, it assumes 1. So you could put a 1 here if you're doing calendar, but it just assumes that if you don't put anything. So you could just, if you're doing a calendar lookup, you would just put in one argument, or one argument here. Okay, and then this one here is just moving forward 40 days. So it's looking at the current, and by the way, this is doing a date time. Okay, so that's going to be a little bit different. That's why there's a 1 here. But these will end up doing the same thing because GoldSim keeps track of the date time based on the start of the simulation, which would go forward the same amount of time forward. It's just showing you that there are two different ways of entering the information. So what the result is then is we have the flow data in red. That's the actual time series. But what we do at the very beginning of the simulation is we look ahead. So the green line's looking ahead just 20 days and telling us what happens before it actually occurs. The blue's looking forward 40 days. Okay, so before I move on, I got some good questions that I forgot to look at from our last discussion of time shifting. Somebody asked, could you also use a vector time series? And so I'm assuming you're talking about doing a time shifting using a vector. I know what you're talking about. So let's go back to our previous example. Let's see, time shifting options. Okay, in this model, we use a year select function to look up for multiple time series. We're doing a time shift for multiple time series. This one has units of cubic meters per day, and this one has a units of millimeters per day. And so it really makes sense to have multiple time series elements in GoldSim. Now, okay, you could set up a vector time series that has no units and then apply the units afterward. And so you could have a vector that has both the flow and the rainfall inside one time series, and then you could use just the regular shifting, and yes, that would work. But that requires that your units are consistent, or that you remove units, which is, you don't want to remove units in GoldSim. So if you don't have consistent units between your time series, I would definitely recommend this way. If you do have consistent units, yes, I would definitely use a vector time series in that case. So I hope that answers your question. The next question was, is there any correction factor to address leap year issues in the time series? We don't have any built-in, any correction factors built in. These are typically not even noticeable when you have a long time series, a long duration time series with a short simulation. Where it can pop up is if you have a short duration time series and a long simulation like we have in this example here. And honestly, if you're going to go this route, if you're going to have a small repeating cyclic time varying input signal in your model, I would question the use of a time series, to be honest. I'm wondering if maybe we shouldn't even show this example. I would use a lookup table if I were you, if you're going this route, and then that way you can deal with the differences in leap year yourself, because it just makes sense. If you have something that's recurring like that in a cyclic manner, then the lookup table is very handy for that. You just look up by the day of the year, for example, on data that goes from 1 to 365, and then you could do something with a leap year. Okay, I hope that helps. Let's see. Okay. All right. Moving on. So let me know if there are any questions about this look ahead, this lookup function. People use this a lot. It's very powerful. In fact, you can do some kind of high-powered statistical analysis and things of your time series now that you have the ability to do a lookup function. So what are some things you can do? Well, here's one thing you can do. What if you wanted to do a scatter plot that compares it compares point pairs in 2 or more time series elements? So let's say we have a rainfall and a runoff time series. The data coincides, so you have data that starts, 1932 all the way to 2012. And this is rainfall, millimeters per day, and then you have runoff from that same location, measured runoff, different units, but same time period. So this is data that's from the same site, let's say, in our project, and we want to do a scatter plot that compares the point pairs of these 2 data sets. What we can do is we can run a Monte Carlo simulation that it's static. Okay, so these are the simulation settings. They're static. There's no duration, but we are running lots of realizations. And it turns out that I'm running as many realizations as we have, I think, rows in the time series. Let's just check. So I have how many rows? Oh, I have 29, 22. So I could put 29, 22 in here. And then what we do is in this expression, we say, okay, I want to do a lookup on the rainfall time series. I'm going to start with the first date, first row in the time series, and I'm just going to walk through each row of the time series. And then by doing that, I can use a scatter plot to see how those points compare. So I just ran the model. Now note, in your actual model, you probably have, a duration model with, doing lots of things, and this is a pre-processing. It could also be a post-processing of your final results, right? But this is in this case it's pre-processing. This would happen at the beginning of the simulation one time. No reason to do this every single day. It's a one-time thing, right? So you would want to put this into a submodel and just tell this to run at the beginning of your simulation, and then once that's done, you have the data that you need. All right, so now that this is done, I can look at this chart, and it shows me a scatter plot of how runoff and rainfall compare. This chart's not super interesting, but I can do other things, like I can look at a distribution result of this. Interestingly, if I put this into a submodel, then I could expose on the interface of the submodel a statistic. For example, what's the 99th percentile of the rainfall? And some of those other things we looked at earlier, where we're doing, the peak annual amount, we could export those statistics out of the submodel and then use those for the remainder of the simulation, which could be very useful. So rather than processing this stuff in a third-party tool, you could do this inside the model and have a submodel call this routine. All right, another one. So I mentioned how you can pass statistics out of a submodel. Let's say that we have a model. This is, again, a static model. It just runs deterministically. All we're doing is just trying to get a vector of peak flows from a history of a simulation. So let's say you have and this is a very simple simulation. It's actually just one element. But let's pretend like you have a big model in here, and it's generating outputs. It's generating a time history output. So if I run this model, let's say you have a history that looks like this. Okay, this is not a time series. This is an output of a model. All right, and it runs many realizations. So if I walk through the realizations, it all looks like this. Okay, so it's walking through time, many realizations. Lots of information is coming out of this. Well, it turns out that now in GoldSim, if you go to expose an output from a submodel, here's our submodel. If I go to the interface, now I have an option on how I want to export time histories. I can export an entire time history from a model now, and I have options on how I want to export the time history. I can export the 99th percentile history. So this is supposed to be that big wow moment, because this is pretty cool stuff that we haven't been able to do before. But anyway, so I could also export, individual realizations, or the last one that's calculated. But the nice thing about the statistic is I could say, well, what's the average output, average time series output from the simulation? In my case, I just looked at the 99th percentile. So what that corresponds to, if I run this again, if I go into the submodel, the 99th percentile would be this pink region here on this chart. Let's see, we could also look at a statistic. Whoops, custom statistic. No. Yeah, here we go. Percentile 99. There we go. So this is the time series that I can export from the submodel. Now, what if I wanted to do statistics on that time series? What if I wanted to know what the mean of all those points are? Or what if I wanted to know the maximum of the 99th percentile? That's the kind of thing that you can do now. So I can bring that time series out, and I'm linking that time series. That's how you have to bring it. That's how you connect to a time series that's been recorded inside of a submodel. I use the linked option. So the data source is linked, and I just linked to the output from the submodel. And now that this is a time series, I can do a lookup on that time series. But I'm also generating a vector. I want to generate a big table of all these values. And now once this, and so I call that that time series, I do a lookup on it, and row minus 1, row is the current row inside this vector. So there's a lot going on here, and maybe what you could do is, if you end up looking at this model, you want to do something like this, you might want to just send us an email, ask us about it if you have more questions, because there's a lot going on here. But this is the vector constructor. Okay, and a vector constructor is what's used to generate an array on the fly in an expression. So I'm generating this vector, and I'm saying each row of the vector, starting with row 1 of this vector, which in this case is going to look up the first value in the time series, and then the next row it looks up the next value, and so forth. So I'm just converting this time series into a table in which I can do a statistic on. So then I can come over here and I can do a statistic like the mean value of all those numbers. I can plot a bar chart of all the numbers. This is the time series, but the reason I wanted to put this into table form, into an array, is because I can do calculations on the array. So anyway, a lot's going on there, but think about if that's maybe applicable to what you're doing. If you're interested, let me know. All right, so here's the most complicated one. The only reason I want to show this to you is just because some of the things you can do can be interesting here. Here's a model in which I have, I'm running just a static model, but I have a time series of rainfall. If I open this up, it starts in 1948, and it goes all the way to 2013. And these are hourly rainfall amounts. This was converted from metric. That's why these numbers are so weird looking. It's imported from Excel. But what I'm doing is the first thing I'll do is I'll process this time series and I'll look for rainfall events. I'm going to extract out the events from this time series. So I walk through it and I say, okay, this meets criteria. This is an event. And I store information about it away in a table. I go to the next thing. Next time it triggers an event, I say, okay, here was an event. And what I mean by event is it was a storm. If there's only a tiny amount of rain, I skip over it. I say that's not a storm, and I walk through this whole series, and I so inside this process time series, I'm generating a table of I'm counting the storm, so I have a number count. I calculate the duration of the storm. I calculate the depth of rain during the storm, and the peak intensity, so forth. All of those parameters are calculated in here. If I open this up, you'll see that I have the container here for storm depth, duration, intensity. I'm calculating those things in there. I have some criteria that must be met to determine whether a storm has begun. And when it ends, then I calculate the duration of the storm, or the count of the storm. Anyway, all of that stuff happens in here. Then I pass that information over to my statistics submodel, in which I then can look at the statistics of those parameters, a probability distribution of the depth, intensity, and the duration, and I can look at how they correlate to each other. With that information, now I can generate stochastic parameters to represent those same variables. So then I can do a precipitation generator based on the values that I got from the original historic time series. And so when I go in here, I have stochastic elements that are, if I open these up, externally defined. So this is another new feature in GoldSim where you can pass a distribution from a submodel out to be used somewhere else. And in this case, I'm taking the distribution that I calculated from the time series, and I'm passing that into the definition of this stochastic in which I sample from in order to generate a new storm, a synthetic storm. So when I run this model, what this does is right now it's importing from Excel, and now it's running. So it's processing this 50 years of hourly record. It's finding all of the events, calculating the parameters, and then it's pushing those the tables of information over to the statistics where I generate the distributions that I then pass as external distributions over to the precipitation generator. And I got a being there. I'm not sure where that came from. Did I get a, no, it looks like it's okay. This didn't take this long last time. Okay, so while we're waiting for this to run, do any of you have questions? Somebody asked, when GoldSim gets past the end of the time series data, will it automatically loop to the beginning? Yes, when you're using time shifting. The answer is yes. Okay, so the model finished. Now we can walk through each of these submodels. So in the process, the time series, well, there's not a lot to look at. The plot just looks solid because there are so many storm events over a 50-year period. So let's not look at that one. But the statistics, this shows us what the depth distribution is. So these are the depths that I calculated for each of the events. And if we look at a table, you can see that we have all these events, and we just ran this for a whole bunch of times. So 2,598 storm events. How did I know how many rows to put in here, or how many realizations? Well, what I did, in the first submodel, I calculated the number of events that occurred. That was right here, storm counter, 2,598. Then what I do is I pass that number into the interface of the next submodel as the number of realizations to run. So we're being efficient here, right? This submodel will only run the number of realizations that we counted storm events for. So then we come in here and we can look at what's the depth to duration. Whoops, I need to close some things here. Move this over. Oh, there we go. So this is the correlation between depth and duration of the storms. Then I can take that information and I can bring that over here, and I can now generate synthetic rainfall events. We can look at each individual rainfall event by going through these. So some are very short events. These are number of hours on the x-axis. But now we've created rainfall events that are based on the historic record. All right, so that's the end of our webinar. Thanks a lot for joining. I hope that was useful for you. We went through a lot of advanced features, but these are a lot of quite new features that are coming out in GoldSim 11.1, hopefully in the next few days. And so I highly recommend that that you start using it. We do have a beta available right now. If you're interested in using it now, it's feature complete and it's just awaiting documentation, which should be done shortly here. So thanks again for joining, and hope to see you next time.